Ted Neward on the ops side of DevOps.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome back to the show. You can go to www.azuredevops.show to see past episodes and show notes. I'm your host, Jeffrey Palermo, and really excited today here in his home of Redmond, Bellevue, Washington, that general area east of Seattle.
We call it East Side Seattle.
That's right for the MVP Summit. I'm visiting with Ted Neward, who's an independent consultant and architect, and also the longtime columnist of Code Magazine in the back. And we're going to be talking about the operations side of DevOps. But Ted, how are you? Good to see you.
Well, it's a sunny day here in Seattle. Apparently, the MVP Summit was scheduled precisely for the right week because we do not have any rain and we do not actually have any snow left on the ground for you guys.
It is sunny.
It's supposed to be like this all week, according to the weather report, knock on wood. So whenever it's sunny in Seattle, people are kind of happy because this is like, our allotment of the 12 days of sun that we get in Seattle a year. So, it's pretty good. It's pretty good.
Awesome.
It's always fun when my friends come to town just to see me.
Right.
And that other Microsoft thing, but yeah, mostly to see me.
Right. So we are recording from the day before the MVP Summit. So 2,000 Microsoft MVPs from around the world descend on your hometown, and you're not doing your Shez.
Yes. Hello, Keith Elder. We're thinking of you.
Shez Neward house party today.
Yep. Yeah. Just, a little bit too much stuff going on this year to be able to pull that one off.
Well, you're a professor. I think something conflicted, right?
Well,
what are you teaching?
So actually, I teach over at the University of Washington. I'm a guest lecturer, so it's not a full-time tenured position. But I'm actually teaching the kids mobile dev. So nice. iOS this quarter and then Android next quarter. And yes, finals would have conflicted with the night of the Shea Neward party, and my wife basically told me in no uncertain terms that she is not going to go through and cook for 300 people if I'm not even going to be there to be at my own party.
Right.
Yeah, I can't imagine where she's coming from, right? I mean, seriously, help me out here, Jeff. She's crazy, right?
You've been at everyone before, at least to eat the food.
Well, there's that, yes.
So you have a really interesting take that I think that our listeners benefit from. Because our listeners, this podcast is for people who are developing custom software on the Microsoft platform. And by and large, they're targeting Windows servers or Azure or both. Right. And they're using Visual Studio and the whole realm of technologies around it. But that's who's listening to this podcast. And of course, we've had many guests talking about the automated DevOps pipelines and the practices to shorten the cycle time between making a change and getting things out to the customer. But the ops side of DevOps is just as important. And what would you say for the canonical team of not the Fortune 500 because they're so varied, but the smaller teams that are just they're trying to do a good job, 3, 4, 5 of them. What do you see out in your practice regarding how operations is getting implemented in this DevOps movement?
Well, the biggest concern that I've got, quite frankly, is that in many cases it's not being implemented at all, right? The fact is that, when the guys at ThoughtWorks, many of whom are friends of mine, when they really started pushing this notion of DevOps, what they originally had intended was that we tear down the walls between the silos of developers and operations, right? That in fact should allow both groups to work collaboratively on getting something out into the world, basically. In the same way that a lot of the original Agile programming tactics, right, pair programming and story cards and the on-site customer and so forth, were designed not to get rid of all of your quality assurance engineers, but to, in fact, let them be a part of the project to begin with, to create much more of a matrixed team responsibility as opposed to creating these IT departments where the QA folk live in building A and the ops folk live in building B and the developers live in building C, and the only time they meet is at the company all hands, right? And unfortunately, what happened in a lot of the early Agile discussions was great if we're doing unit testing and we're doing refactoring and we're doing, all this writing code to test our code, we can fire all the QA people. And I watched a number of companies do exactly that and then couldn't figure out why their software wasn't bug-free. And what they didn't realize is that it is absolutely possible to fail with 100% code coverage. Your project can be a complete disaster even if you've got unit tests that exercise all of the code. Because unit tests, by definition, are testing a unit of work, and they don't necessarily test how all of the different parts work together, right? Well, a good QA engineer will be able to try things that you just couldn't even imagine. I mean, who in their right mind would actually do that? And funny enough, QA engineers do that because they know that end users will do that and result in broken software.
They're creative.
They're very creative. Some of the best QA people in the world have just an entirely different mindset. They just look at the world fundamentally differently than the way developers do. And I think a large part of it is because developers are generally looking for, how do I make the software right? And QA folks are looking at, how do I make it wrong? I think just that basic fundamental difference of viewpoint makes a whole lot of difference in terms of how we go and build this stuff. Now, to a certain degree, what we did want to see is we wanted to see, the Agile mindset and QA bringing them into more of a sort of a modern style of QA so that QA folks weren't doing regression tests. We had automated tools that were doing that and thus spawned the notion of a software development engineer in test, right? An SDET. And so now a lot of your QA folks are learning how to program and writing tests against the code, bringing their QA mindset to the project as a whole, but they're not focused on implementing features. They're literally focused on breaking them, right? So we saw an evolution in the way QA worked. And I think we're on the cusp of a similar kind of shift for the operations folks, particularly because so many people are putting things into the cloud. It means that ops folks no longer have to worry about switching out disk packs and ordering
Spiking
a new
hard
server.
drives.
Yeah, exactly. They don't have to worry about some of that stuff. Although I will note that I do think the world probably wants to seriously question whether they want to get into the cloud for a variety of different reasons. Because, for example, when you decommission a server, who is actually making sure that the drive is wiped clean? Who is, in fact, spiking the drive, literally, to make sure that the data cannot be recovered?
Right.
Because we've seen the stories, right? I mean, there have been several investigative journalistic reports about people who are buying copiers from, like, used copy shops.
And they have memory.
They have hard drives, Jeff. They have hard drives.
Of everything they've printed.
Of everything that they've ever printed. And in some cases, the drives aren't even it's not like they just did a fast delete. They didn't even bother deleting them. They just sold the copier as is. And so, yeah, if you go down to some sort of hardware restoration or, where people sell these used copiers, right? You can get a copier from a law office or from a doctor's office, and you can see people's medical records, legal records. They can see confidential financial information because people were copying it and then never bothered wiping the drive.
So what you're saying is the scene from Office Space should be implemented everywhere.
If that copier was used to copy sensitive documents, which is probably true of 90% of the copiers in the world, then yeah, they really do need to go out into a field with a baseball bat and beat the living stuffing out of it. Absolutely.
If you haven't seen the movie, that's what they did to this copier.
Yeah, because it was a terrible copy machine. And I have felt that way about several printers that I have run across in my years in the corporate world. No, that was cathartic for a lot of us, especially in the 90s when everyone was trying to use the shared printer and whatnot. Yeah. Oh, yeah.
It just didn't work.
Yeah. I actually, on that subject, I read an article probably about a month or two ago about the making of Office Space, Mike Judge, this being his first movie and whatnot. And they said for that particular scene, right, there were a lot of the movie executives really did not want that scene in the movie. That was like the most controversial scene, especially because they got the gangsta rap playing in the background, and they're there with baseball bats. And actually, they filmed it like 4 or 5 times and just kept putting the same copy. They just kept putting the pieces back into the pile so they could beat on it longer, so it would have more of an effect as pieces fly everywhere in the middle of that field. But if you're a geek and you haven't watched Office Space, I seriously call into question your geek cred.
Right.
You need to watch that movie. It's amazing.
And quite a bit of that was filmed in Austin, Texas, and so that's where I live.
Right.
And I've gone around and saying, okay, that scene was there, and that scene was there.
Yeah. But I mean, going back, right, when we start talking about the cloud and we start talking about multi-tenancy and we start talking about all of these things that the cloud does for you, right, on the one hand, that's great because it means that my ops folks can actually focus on other things, right? They can start thinking about more of the soft administration as opposed to the hard administration of those clusters of machines.
Right. It's taken the screwdriver out of their hand.
To a large degree. And part of the question that I think any company needs to ask is, do we want the screwdriver out of their hand? If we put this data up into an Azure data center, sure, Microsoft is going to have armed guards surrounding the physical machines at any given point in time, which is good enough for most folks, right? But if you are in a particularly data sensitive space, right, what does Microsoft do with those drives when they're done? Can somebody, if you happen to be co-located with another system that doesn't pay a whole lot of attention to security, could their vulnerabilities end up affecting you, right? Because if I can go through some poorly written system to get a snapshot of the disk, right? I mean, figuratively speaking, if I can get a photographic picture of the disk sectors, right? Then that's potentially my data that's being compromised, and so on and so on and so on. So there's a whole bunch of that kind of operations that the cloud means you don't have to do, but you also don't get to do, right? And that's the kind of thing that a traditional hardware IT ops team would help you sort out, right? That would literally be a part of their responsibilities. And do I want to let that go? Do I want to not have control over that? That is a reasonable question to ask. But the other side of it is literally, the ops folks, people who have been doing operations for 10 or 15 years, they have some really gnarly stories that they can tell. And they are in some respects sort of a halfway, mental mindset between QA folks and developer folks. Because op folks have to figure out how to make stuff work, but they also have to figure out why stuff's broken. And interestingly enough, recently I just left my position at Smartsheet. We had a situation where we had a couple of servers running in an on-prem environment. That's a long story in of itself. But we actually were seeing some very bizarre errors, right? Absolutely bizarre errors where all of a sudden, 2 MySQL databases on 2 separate machines would just up and die, just stop responding. And this one guy, Scott Weimer is his name, in case, Scott ever listens to this podcast. This was you, buddy. He actually tracked it down. I mean, he dove through, the software, the database, the operating system kernel. He tracked it all the way down to the fact that apparently these 2 Dell machines that we had purchased had been issued network cards with the same MAC address.
Oh, wow. Okay.
Which the chances of that happening are infinitesimal, right? I mean, they just happen to get the same MAC address because the timestamps happen to occur in the same millisecond window or some ridiculousness like this. I don't even know the full story. But the fact that they had the same MAC address, I mean, if this had been happening in a cloud environment, first of all, how would you ever have tracked it down? Right. Now, it is fair to ask, well, would that have still been a possibility? Sure, if these 2 blade machines are next to each other in the rack and 2 different MySQL databases are each trying to compete for that particular MAC. How would you even track this down? And how would you be able to go through the cloud technical support to get the necessary level of support to track this down? But this highlights the other thing, which is to say a lot of developers frequently will know the space in which they run, right? And so if you're a .NET developer, the lowest you'll go is the CLR, right? A lot of .NET developers are like, yeah, I know my C# code compiles to something,
Right.
and it runs, and that's it. That's all I care about. That's all I know, right? Whereas the ops folks, they can't, right? They can't hide with that. They have to understand how the CLR sits on top of the operating system, how that in turn sits on top of hardware, because they have traditionally been responsible for the whole. I mean, literally, the ops guys are, they are the last line of defense in keeping the servers up and running. And so they have a very different mentality from a lot of the developers of the world. Because developers, right? Remember, it's Facebook. It's developers that want to move fast and break things.
Right.
And ops guys are like, don't move at all and nothing will break, because they care, first and foremost, about the system having 99.999% uptime. And if you do the math on that, by the way, that works out to 5 nines. Availability works out to less than 5 minutes of downtime per calendar year.
Yeah, that's essentially nothing.
And developers, I mean, you try to have that conversation with developers, and developers will frequently say, no, man, we got to get out the door fast. We just got to ship it. If we're at 80% availability, that's good enough.
Right.
The ops guys are like, no, it's not, because I'm the one who gets paged at 2 a.m. when something is down.
Right.
And historically, this has set up contention between the developers and the ops guys, because developers will say, yeah, sure, we shipped it. It ships. And so, yeah, you ops guys, you take care of it now. Developers had not historically been feeling the pain of some of their bad decisions, because once it's in production, we never see it again. Right.
Especially if the system is in the revenue value stream rather than just internal staff work.
Right. And so for a lot of folks, the notion of DevOps was about developers being aware of, being engaged with ops, being able to see some of the ramifications of those decisions. What a lot of companies seem to have interpreted that to be is, okay, developers have to wear pagers now. Developers have to get paged at 2:30 in the morning when the system goes down. And that was never really the intent, because now it's dev replacing ops, and you lose that mindset that the ops folks have. And just like I didn't ever want to see the QA mindset disappear, because that is an absolutely critical part of how we get not just software, but working software. The ops mindset similarly needs to be there so that we can get working software that continues to work. And developers, I mean, right now, developers aren't being taught these things. Developers aren't, they're literally incentivized to ship stuff without concern for how many bugs there are or how long it stays up.
Well, the industry is just scrambling to find enough developers. And if you've gone through a coding school, you call yourself a developer, and boom, off you go to your first job.
And there are some very, very good folks who are emerging out of those coding schools. Don't get me wrong.
Oh, yeah.
Right?
Oh, yeah. But as far as an education, a curated education
to be fair, right, I go back 20 years when I was attending the University of California at Davis. I don't ever remember seeing Intro to System Administration anywhere in the CS curriculum.
None of us had it either.
Right.
But as long as, the industry's still young, but we didn't have it when we were going through our education, but it's still not there now.
Right.
So we've all learned what we know through what we've done, just like the people coming up are going to be.
Well, and that's the thing is, these, the whole mentality of the DevOps pipeline, the whole mentality of developers automate all the things and we're done, suggests that the current generation of folks who understand testing and ops, there are not going to be any replacements for them, right? Once they die off, figuratively or literally speaking, there will be nobody who has that mindset anymore. And developers are going to have to learn all of that themselves. I mean, right now, talking with a bunch of folks in the recruiting space and whatnot, I mean, again, when I was at Smartsheet, we were looking for full stack developers, people who understood the front end and the back end and can work in the database and whatnot.
The generalist.
And they were hard to find. There were a lot of people who understand the front end but didn't have as strong a set of skills on the back end. There were a lot of folks who had good back end skills but didn't really get the front end, because that's a lot of stuff to try to keep straight. Now you're asking them also to have a QA mindset and to have an ops mindset. And by the way, 1 week in 4, you're on call, so you have to be within 15 minutes of your phone at all times, and you have to be someplace where you can log in. and be able to fix things remotely, which means you have to have a decent bandwidth connection, which means, by the way, that, no vacation for you during that week, because if you're not someplace where you can immediately jump online and fix something, right? And honestly, I don't know how many developers I know that are actually ready to sign up for that. On top of which, and we need to make sure that every developer as part of the entire development team has all the access to all the resources necessary to diagnose, troubleshoot. And we probably should figure out how to teach them how to detect the denial of service attack so they can understand how to rewrite the IP packets through the network proxy, through all of these things that developers historically have not had to learn. Right? We stayed in our lane, bro. We just wrote the code that presented the UI, that did the communication with the database, just believing that the database would be there as long as we gave it the right magical, connection string, right? And everything else from, literally outside the process boundary, everything else would just work, right? And we were able to do that because in many cases we had ops folks who said, what exactly do you need? All right, you need a machine over there named this, and they set all that up, right? And so, from the perspective of, the so-called long tail companies, right? The notion of, generalists becoming more generalists, right, definitely seems to be the direction that the industry wants to go. And I don't know if that's a good direction or a bad direction. I do know that there are a lot of small companies that have, they have suffered because of all of this additional complexity that we've introduced in terms of all of these different software packages, all this different administrative stuff, all this different stuff that I feel bad for anybody who's learning Azure for the first time and they wander into, the Azure command and control console, and it's more complicated than an F-14 cockpit. I mean, it's just ridiculous how many different options and choices and things are sliding in and out everywhere. And it's no better for AWS and it's no better for Google Cloud.
Not for any of them.
No. Yeah. I mean, just all of them are in this feature smorgasbord of we just want to throw all the things in there, right? And if you want to try to selectively, I just want to set up a really simple, website with a database backend and.
Well, even today, how many of those do we actually need? How many runtime architecture topologies do we really need for most systems?
Well, and this is where
you got your web.
Yeah.
You got a back-end job. You need to store data. Maybe relational blob files. I mean, there's a few ways. But it's not an infinite number.
Well, and the thing of it is, the bigger cloud players, AWS, Azure, Google, right? They are trying to build a cloud, a collection of clouds, however you want to think about it. They're trying to build a cloud that can cater not only to the Fortune 500, right? Because that's where they see the really big payouts coming. If we can get Ford to move all of their stuff into Azure, bonuses all around. Everybody wins. Yay.
Right.
Because that represents a huge bill, basically, to Ford. Netflix and,
American
Uber.
Airlines is a huge one that is reported to be paying a whole bunch because they still have tons of Server 2003 hanging around that they haven't moved.
Yeah. And so if you, to a certain degree, the answer to your question is yes, there are an infinite number of topologies because every Fortune 500 company out there has a different topology if they were to try to do some sort of lift and shift, right? But when you start talking about the small to medium business, right, a lot of their IT needs are very, very straightforward, right? And so, Amazon recognized this in some respects when they said, look, we want to do is we want to just create a very simple packaging of the core basics, right? What they called their Elastic Beanstalk, which was a Java Tomcat server and a MySQL database and some very, very basic load balancing proxy. And boom, here's a package. You just fire up one Elastic Beanstalk and poof, you've got what you need to host a, what we used to call a dynamic website, right?
Yeah.
And Azure definitely could use with something similar, but more importantly, just from a perspective of an admin console, right? If you're a 5 to 10 year industry veteran, right? How much do you really know about IP routing tables? How much do you really know about, even I mean, I've met people who are 15-year veterans who really don't understand how DNS works, right? And these are all the things that traditionally your ops folks learn in their first year of being an operations engineer. Who's teaching that? Who's teaching them? Who is, who is teaching that information? Because again, as we discussed, it's not coming out of schools. Typically, you learn that on the job from the senior ops guy that you apprenticed to, right? In the same way that a lot of the things we learn in development, you learned on the job from the people that you were apprenticed to, right? But with this movement towards we're going to DevOps all the things, we're going to automate all the things, we're losing those senior folks because companies, they're number one, those folks are expensive. And, if we want to go through a round of cost cutting, well, get rid of the expensive folks, right? Because if we can't measure their value against what we're paying them, and how do you value the idea of the server not crashing in the middle of the night?
Yeah, risk.
It's
a guess.
It's hard to measure a negative thing, right? It's hard to measure a thing that doesn't happen.
Because they do what they do, we don't lose money,
right?
But with a surprise,
right? Exactly. And so, do you say basically that every day that things were up and running normally is value that was generated because they did their job? I mean, I think that's a reasonable case to make, right?
Well, that's where the CIOs, the good ones, have that judgment. They understand how we mitigate the risk of something going down,
right? That's
in the critical path of revenue.
And, for the companies where you have good CIO, where you have a good vice president, where you have a good director, right, depending upon the size of the company, who can say, no, those senior folks, they're important, they stick around, great. The problem is when you get to the small to medium businesses like you're talking about, a lot of times the people who
you just have developers in those companies.
Exactly.
You just have a handful of developers,
right? And
you have maybe somebody who was a developer, was an ops guy who's the manager of that group, or sometimes the VP of operations. The developer team has to report to somebody.
Right.
That's what goes on. So they're just trying to do their best. So what should they be studying, and what should they know? What should they put in place for their regular applications? Web application, a few back-end batch jobs, SQL Server, maybe some files that are being read, and maybe some queues.
Right.
I mean, those are all the normal things.
Well, I mean, part of it is, I think, my personal opinion is that everybody should know one level below the level at which they work, right? So if you're a developer, if you're a .NET developer, you should at least be able to read and understand IL bytecode and understand what the CLR does, right? Now, particularly if you're going to take on more of an ops type role.
Let's get concrete.
Sure.
How should they go about learning that?
Well,
I have an idea, but
there's a variety of different resources out there, right? I mean, from the one hand, there's places like LinkedIn Learning and Pluralsight and all that kinds of stuff. There's a number of books, that are available in terms of how the CLR works. There's a ton of, if you Google CLR implementation, right? I imagine Google will present you with thousands of hits, some of which will be actually useful. The key thing, I think, really becomes, and this is a thing that I actually advocate for a number of teams, dev, QA, ops, whatever. What I think business needs to understand is that, like the legal profession, like the medical profession, the world does not stand still, right? The technology space arguably changes much more quickly than either of those two, and yet doctors and lawyers both are explicitly given time to come up to speed on whatever the latest changes to the law or whatever the latest developments in medicine are, right? Doctors routinely get subscriptions to the New England Journal of Medicine. Lawyers are frequently required to do bar association meetings and so forth to make sure that they're kept up to date on what's happened, right?
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
So I would recommend Jeffrey Richter's CLR via C#. And it was called, I think, Applied applied CLR or applied .NET runtime or something like that back in the .NET 1.1 day, and then he renamed it to CLR via C#, and it goes into all the guts of how your C# code becomes IL and then is run, garbage collection, assembly boundaries, segmentation of memory. I read that book, and nothing else comes close to the depth that I've seen. So I'd recommend that one personally.
And after you've read that book, you can actually go up to the core CLR page on GitHub, and in the documentation folder, they actually have what they call the book of the runtime.
Okay.
Cool. And the book of the runtime is basically the closest you're going to get to the source material without actually reading the source code yourself, right? There is an older book that actually in many cases covers a lot of the how the CLR actually works. If you're comfortable with C and C++ and just a tiny smidge of assembly, SSCLI Essentials by, who's that by? Oh yeah, that's right. I wrote it. Like 15 years ago when the Rotor source code came out, right? Rotor was the shared source CLI. And that actually
.NET 1.1 or was it just 2.0?
No, it got to 2.0, but there was a 1.1. Yep. So the Rotor bits shipped officially at the same time that .NET went 1.0, because the Rotor bits were actually intended as the I don't want to call it the reference implementation, but they were an implementation of the ECMA standards that
so
.NET,
other people could write .NET compilers
and make sure that would cross-compile and work correctly.
Like the Fujitsu COBOL.NET compiler, things like that.
Exactly. And it got a significant tweak in 2.0 because .NET introduced generics. But then after that, for the most part, it just kept on keeping on. Because there really were no substantive changes to the runtime for many, many, many years after that. Now, the Rotor effort has since been long since abandoned, right? I don't even know that you could find the Rotor tarball anymore.
Well, don't we have we're on the third runtime? We had the 1.0.1.1, but then the 2, and then the 4, and we're still on the 4, right? CLR4?
For the most part, yeah.
Yeah, so since CLR4, the .NET Framework, .NET Core have all just built on the same runtime. So you learn the guts of CLR4, and you're good for a long way.
Well, and part of the thing is understanding that level below where you work, right, will get you introduced to the notion of what processes are and so forth. And again, from an ops perspective, they work at the operating system level, right? So in many cases, they want to know one level below that. So if you're a developer who's taking on a lot of the operations type management and so forth, then you really do need to know one level below the process structure as a whole, which is to say you do need to understand how networking works, right? What does TCP/IP mean? What's the difference between TCP and IP? And why is that difference important? How does TCP/IP differ from, say, UDP/IP, right? Or any of the other protocols that we've got available out there. And you need to understand a little bit about, how machines are addressed and how we get packets from one end of the internet to the other, which is to say the whole notion of routing and domain name services and so forth. What is a proxy? What is a reverse proxy? Do I really need one? Right? And there are a lot of traditional academic books, Douglas Comer or W. Richard Stevens, right? A lot of this is all, you pick up the title of W. Richard Stevens, Advanced Unix Programming. You're like, what? I don't need to know Unix. I want to know Windows. Guys, the Unix networking TCP/IP stack is derived off of Berkeley BSD sockets, which came out of the Unix environment, right? So in many cases, you're going back to some of these books that are 10, 15, 20 years old to understand some of this technology. And I do wish, I really, really wish that, coding schools and university programs, right, to talk about both ends of the spectrum, would spend some time talking about some of the history of computing, because that would explain how some of this stuff came to be, and that would explain why some of these things evolved the way that they did.
Yeah.
But they don't.
Windows 3.1, you had to choose a networking stack to install on top of the operating system.
Yep. You could do TCP/IP, or you could do NetWare.
Good old WinSock.
Yep. And there was NetBUI, and there was Token Ring, and there were a couple of other things, right? TCP/IP was not a guaranteed win.
So a previous show we had Eric Hexter, who he actually was one of the key people on the MVC Contrib project, and he was a co-author with a book of mine. But he has this model for DevOps diagnostics and the level of logging and what you need to look at and how you need to configure things. So listeners, go back and listen to his podcast if you want some just concrete guidance. But what are some of the other things? So you got this long tail, small dev team. They're putting their stuff into Azure. What are some rules of thumb they could come away with?
So actually, I mean, if we're in the if we're in the habit of recommending things, I did a book.
And in this podcast, we try to be really prescriptive.
Yeah.
We try to not say it depends. We say, no. In the 80% case, you're just in a regular application, non-Fortune 500 specialized scenario. Just do this.
Well, and so
then change it later if you think you need something different.
Yeah, because it will. I mean, the world will change regardless whether you want it to or not. Yeah. But no. So one of the things I did a number of years ago is I wrote a book called Effective Enterprise Java, which may strike it as odd because we're on a Microsoft podcast here. But the point is that a lot, like 90% of the various rules that I talked about in there really weren't Java specific. They were more towards building an effective enterprise system, period. And so, for example, one of those rules was, remember monitoring, right? How are we going to monitor this? What do we need to track? How would we know when, literally, if I were to figuratively walk into the server room and turn the power off on the machine, how would I know that this machine is no longer responding to requests, right? How would I know that this machine starts failing? How many error messages am I going to start to get, right? And this is the most practical thing that I can think of is you have to start cultivating that mindset, right? How can I break the system? What happens when I break the system? How do we now put necessary hooks into place so that when the system is broken, because that's the key thing. It's not an if, it's a when, right? This percolates all through every layer of the stack, right? So from the whole notion of, do I set up a redundant backup, right? Do I set up another operating system image in Azure so that I can have a backup of the data? And how often, how often will that data be backed up? Is that some sort of hot replication? Do we do it once a day? How much data are we willing to lose when the database fails, et cetera, et cetera?
Right.
From there, all the way back into your code, which is to say, if you're doing a try catch block and you have an empty catch block, right? I basically, as part of a code review, I tell people, okay, great. If you've got a comment in there that says this should never happen, then I'm going to tell you to
take it out.
No, don't take it out. Put system.exit.
Yeah.
Right? Literally kill the process. Right? Kill the process because if it will in fact never happen, then this line of code should never be executed, and it's perfectly safe to put something in here that will crash the entire process.
Right.
And the
funny thing loudly.
Exactly. And the funny thing is when I advocate for this with developers, when we do this in a code review, they're like, wait, what do you mean? What do you mean? What do you mean you're going to kill the whole thing? I'm like, well, this should never happen. They're like, yeah, it should never happen.
Let's just email the CEO right here in this catch block.
Exactly. And if it should never happen, you're saying it never could happen? Well, no, it could happen. Then maybe we should do something about it, right? It's that mentality, right? It's that mentality that anything could break at any given time. How would we know it? How would we fix it? How can we make it easier to detect it? And therefore, how can we make it easier to fix it, right? That mentality, that's not going to be something you get out of a book per se. That's going to be something that you practice, right? How will it break? And so in this case, Eric's talking about logging and providing all of this information. And then you turn around and say, great. So if I've got, a huge encyclopedia of log messages, how do I find the part that failed, right? How can I detect which part failed? Because here's the thing, the one drawback I've seen to voluminous logging is the fact that we kind of have an expectation that somebody's actually watching those logs.
Yeah, without the automatic queries tied to alarms.
Exactly. Exactly, because the alarm then becomes that proactive notification to say that something is busted, right? So how do I set up that alarm, and how do I get that alarm to point to the right spot in the log file to tell me where this went wrong, et cetera, et cetera, et cetera, right? It's this mindset that's absolutely the critical part of this. And, in many cases, the best way to figure that out is to literally try turning things off, right? It's simpler than ever to do this in a cloud-based environment, to say we're going to set up, a clone of our production environment, scaled back if necessary, so it's not ridiculously expensive. And then, just leave it up, leave it running, do deploys to both places, but then run fire drills.
Yeah.
Right? So what happens when that server goes down? What happens when that queue gets filled with meaningless messages? What happens when the web server disappears? Right? And you can, in some cases, write code to simulate that. Right? I'm going to write a little program that's just going to pump that queue full of messages as fast as its little heart can possibly put them in there.
Yeah.
And let's just watch what happens when the queue fills up and spills over. What do we do then? Right? So there's lots of different things we can do to test this, but it's the key aspect here is the mentality that says, I want to break the system so that I know how it breaks, so that I know how fragile it is in some cases, and so that then I can figure out how to recover from it. And then I'm going to run these on a regular basis, right? I advocate the idea that, frankly, you should be running a fire drill of some form, depending upon the size of your group, once a day, once a week, once a month, right? Literally so that you can make sure everybody is comfortable with figuring out what's rusted and how do we recover from it. Because there is no worse feeling in the world than being the new person on the team, and you get that phone call or you get that page at 3:00 in the morning, the system is down, we need you to fix it. You go downstairs, you open your laptop, you log in, and then you're like, now what?
Right. And you remember the turn of the millennium where we really went from a transition from where, for the most part, you might know most of the people who used your software to now it goes on the web, and now there's no way that you know or can even speak to all the people who are actually using the software. It's a totally different paradigm.
Oh, yeah.
And of course, the technologies then, the services, especially VB6, Com Plus, Windows services, notorious for just failing, for ghosting, for still being up, but just not doing anything.
Yeah.
And so, because .NET backend processes that just run all the time, they're so much more reliable. They can lure us into complacency, and then, it failed. And then maybe it fails, twice a year, and that's not enough business pain to change. But you're right. We need to. Scrum had this concept of definition of done, and for a lot of teams, it was, it's ready for production. It's done. So and so UAT, it passed.
Right.
But now with DevOps, I think the definition of done is expanded to all of the functionality, including the functionality that we have specified in the cloud environments, like centralized logging, the alarm configuration. And so hasn't the surface area expanded upon which we should have testing?
Absolutely. Right. Absolutely. I think, I think basically as a combined dev, QA, ops team, right? When I was running a dev team at Smartsheet, we very specifically included, whenever I did a team event, we invited the SRE folks, the site reliability engineers, that was the name of their group. We invited the ops folks, and the QA folks actually sat right next to my developers, right? We wanted that to be a single cohesive team that all were pulling together, and we wanted to test all aspects of the stack. We wanted to test everything that we possibly could. In our particular case, we had worked out with the ops folks that we were going to do is we were going to put all of our, deployment, the end result of our CI/CD pipeline would be a Docker image, which they could throw into, in this case, they were using AWS, but Docker image was the ultimate build artifact that got tossed into the cloud. But part of what we were doing is we were explicitly testing that image against local cloud deploys, for lack of a better term, right? How do I run this locally on my machine, right, to make sure that it will work? What happens if, bang, we kill the database? What sort of results do we get? What failures do we get? Et cetera. And, that really paid off in the long run because, the fact that we included the ops and the QA folks in the project discussions, literally the week after the team was first formed. I hired the dev lead. We hired our first developer within a day after that. But then before we finished fleshing out the rest of the development team, we had the ops guys and we had QA guys, being a part of this, right? And, as the team grew, we grew the ops and the QA presence accordingly. And they just all worked together, right? They were one unit, so to speak, that happened to report into 3 different parts of the org. And we tested everything we could possibly think of, right? Now, to be fair, this was not an app that needed to have 100% fault tolerance, right? It did not have to be up 100% of the time. And so we would get to certain points where it's like, well, what happens if X, Y, and Z? And at that point, I or somebody else would simply say, well, then the app is down. And there's nothing we can do about it. And we wait until, stuff happens. Because there's always going to be a point. There's always going to be some element where you say, well, what happens if heavily armed Soviet commando forces storm the data center and kill everybody? Right. Well, then they have your data.
If the generator runs out of fuel after the electricity's out.
Yeah, exactly. I mean, there's all kinds of those what-if scenarios. And, you have to understand that there's going to be a certain point at which, to your point, it doesn't make business sense to try to test everything and fix everything. So you decide basically where that pain point is, right? Where is the point at which you say, it's not worth spending, $10 million to build our own cloud center that uses a different source of electricity than the one that Microsoft chooses to use, right? And even in some cases, there are bugs in software that you say, well, this bug, which is actually a bug that will, make the data center like break into fire, right? It overheats the CPU and causes it to spontaneously combust, but nobody ever exercises that functionality versus this bug over here, which is a minor UI annoyance. It's an irritation, but 2,700 people are hitting it every single day.
Right.
I'll tell you which one I think is the bigger one, because even though the exposure and the liability of the UX bug is much, much lower than the whole data center catching fire, the fact that 2,700 people hit this every single day magnifies the impact of that, even though the data center never catches fire. So part of this testing, this mentality, this triage mindset is not just how bad is the bug, but also how many people are running into it, and how do I make sure that I understand what parts people are running into? How do I get feedback from my users, right? How do they tell me, hey, I hit this and it's frustrating me, and so on and so on and so on. This is where Microsoft, for example, for a number of years has had the little happy face down in the corner where you can report stuff, right? So that this is their attempt to try to get that feedback, right? There were other efforts that I've seen in the past where people have actually tried to, record users' movements through the software so that now there's some privacy issues that go with that. And so your mileage may vary. You have to think about how this works with your particular business model and yada, yada, yada. But again, while I was at Smartsheet, the main core product would actually sort of keep an eye on basically as users moved to the system, so that if they contacted one of our customer service reps, the CSR could say, okay, great. So, what email address? Let me log in. Let me see. Okay, so you went from here to here to here to here to here to here, and you're stuck at this point. Is that correct? Yes. Okay. Then what you want to do next is blah, right? And, that definitely makes a lot of people feel very, very comfortable with the software. But more importantly, it's giving you that feedback. It's giving you that image, that vision of what people are doing with your software, and allowing you to make some of those triaging decisions more effectively, which will then let you say, you know what we found is, we built a whole bunch of infrastructure around our database. It fails over well. Nobody's complaining about the database. Amount of additional dollars we should invest into database infrastructure is zero.
Yeah.
Because it works, and we're not getting any complaints. We're not losing any data. So then you just leave it.
Right.
We do not need to make it better, right? Because that's very much the ops mindset. Once we get it to the point of working, don't mess with it. Don't screw with it, right?
Yeah. Well, I know we're here at the end of the show, but what specifically should our listeners follow up on if they've been listening to this and their minds are sparked? What would you direct them to as to continue this bit of learning?
Honestly, I would direct them to some of the classics, right? The classics of CS, figuring out, how TCP/IP works, Comer and Stevens and some of those books. Certainly understanding, just some of the various management and monitoring tools that are available to them, right? So, for example, Windows Management Instrumentation and some of the other tools that .NET makes available for being able to hook into some of the various facilities that Windows offers.
Mm-hmm.
Accordingly, if you're a .NET Core person, right, and you're running on top of a Linux image, how do I report errors in a Linux environment, right? It's not so much that I want to say these are the books that you should go read, because frankly, there's dozens, there's hundreds of them. One book I think that is generally a general purpose recommendation, regardless of your technical stack or whatnot, is Pragmatic Programmer, right, by Dave Thomas and Andy Hunt. Best non-technical programming book anybody will ever read, because a lot of it is about this kind of mindset, this kind of mentality, right? They have one particular practice they call tracer bullets, right? Because tracers, of course, when you fire, you
can see where they go.
Exactly. You can see where it's actually headed, so you can tell whether or not you're actually hitting your target, right? This is kind of that mentality of, how do I know what I know? How do I know that what I know is correct, right? The philosophers used to have this kind of epistemological questioning all the time, right? This gets us into the whole discussions about being a brain in a vat and the matrix and all of that stuff. How do I know that what I'm sensing is correct? When in the software space, how do I know that when this code is running, that it's actually executing, right? How do I know that the failure is happening in this particular place? How do I know that the software is even running, period? When I deploy this thing, is it even still up, et cetera, et cetera?
Right.
So that notion of tracer bullet is something that we can apply across the entire stack, just to be able to figure out what our monitoring footprint should look like.
And your website, your Twitter, where should people go to find you?
Oh, I don't think people, if they want to come find me, I mean, my Twitter is at Ted Neward, and I have two websites, blogs.tedneward.com and newardassociates.com. But frankly, there are much, much smarter people in the world than me that are talking about this stuff. So don't come to my site for this for this stuff. Go to
they may want to hire you.
If they want to hire me, Google Ted Neward, they'll be able to find me one way or another. But more importantly, again, this is sort of the professor in me. It's like, hey, I don't want to make you read my book. There are better people who have written better books on this subject. Go to those, right? The key thing really to me is that mindset. That's the key. Because if you are focused on trying to learn how to do these things, if you're focused on asking those questions that don't necessarily have easy answers, you will go find those resources. Because, I mean, the internet is a wonderful thing. There's all these resources out there. You just know the right question to ask.
Yeah.
And so hopefully asking these questions will lead them to those resources, whether it's Richter's CLR book, whether it's the SSCLI Essentials book, whether it's whatever. That's the key, as far as I'm concerned.
Awesome. Well, great talk. Thanks, Ted, for being with me.
Thanks for having me.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.